In this video, we're going to take a look at some common calculations done for strong acids and strong bases. So there's a few things that we can do. One calculation is calculating the pH and pOH. pH is a measure of the acidity of a solution. We call it the power of hydrogen. It's a measure of basically the H3O plus ions in the solution. As a reminder, the lower the pH, the higher the H3O plus in that solution. So that means that the more acidic that solution is. Now the pH scale is a logarithmic scale, a log scale, which means each unit difference is a factor of 10 times. Not 10 plus, but 10 times. So if you have a pH of 4 and a pH of 5, the pH of 4 is more acidic. It's actually 10 times more acidic. That difference in one unit represents 10 times. So let's say you had a pH of 3 and a pH of 6. Well, the pH of 3 is going to be more acidic than the pH of 6. How many times more? Well, if you look at the difference, it's 6 minus 3, 3. It's not 3 times though. It's each of those 3's is 10 times. So 10 times 10 times 10, which is actually 1,000 times more acidic. There's 1,000 times more H3O plus ions in the pH of 3 compared to the pH of 6. You could also think of it as 10 to the power of the difference between them, 10 to the power of 3 times. So this is 1,000 times more acidic. So how do you get pH from the concentration of H3O plus, and how do you go the other way around? Well, if you want to find the pH and you have the concentration of H3O plus, you just do the pH is equal to negative log, which is on your calculator, of H3O plus. And that will give you that will basically convert your H3O plus concentration into a number you can put on the pH scale. The pOH is another measure. It's called the power of a hydroxide. So rather than measure the hydronium ion concentrations, this measures the OH minus concentrations. And think of it almost like the pH, but more on the base side. So the lower the pOH, the higher the OH minus concentration is, and the more basic the solution is. And if you want to find the pOH, you would do the negative log of the concentration of hydroxide ions in the solution. So that's another relationship that you can do to find the pOH. Another relationship that you might sometimes see is the relationship between the pH and the pOH. Where you can, if you have the pH and the pOH, if you add them together, you get 14, right? And that's not really a surprise because the scale goes from 0 to 14. But what this means is that if you have the pH, you could find the pOH by doing pOH is equal to 14 minus pH. If you have the pOH, you could find the pH by doing pH is equal to 14 minus pOH. So as long as you have one, you can find the other because they're all related to each other. You can also go the other way around. If you have the pH or pOH, you could figure out the concentration of H3O plus and OH minus by basically reversing your log. So all you do to find the H3O plus is do 10 to the negative pH, and your OH minus you find 10 to the negative pOH. Another relationship we saw in the previous lesson was the KW relationship, where KW, which is 1.0 times 10 to the negative 14, is equal to your concentration of H3O plus. We could also write it as H plus times your concentration of OH minus. So these are all some key relationships that we saw for acids and bases, and we're going to apply these relationships in the context of strong acids and strong bases. And later on, we're going to apply them in the context of weak acids and weak bases. But for now, we're going to focus more on the strong acids, strong bases. This is a little summary for all the different relationships and how you can go from one type of measure to another using the different formulas that we just saw. So in the next video, we're going to take a look at some sample problems to apply those relationships to the context of strong acids and strong bases.